Hey guys, welcome back to the C++ series. In the last video, we covered first set of operators in C++. If you haven't watched that video yet, do check that out. In the second part, we will take a look at the remaining operators. So let's get into it. The next operator on our list is ternary operator. It is represented by a question mark and a colon. If you know if-else blocks, you can think this operator as a short form of if-else. Let's take a look at this example to understand this better. So here what we are doing is we first check if a is equal to b, and if this condition evaluates to true, then we return 5. If that condition is false, we return 0. And this returned value is stored inside a variable called x. So if I run this code, you can see that value of x is 0 because a and b are not equal. But if I change b to 5, and let's also change this 5 to 100 and run this program again, you can see that value of x is 100 because now a and b are equal. This means you can use this operator if you want to perform two different tasks depending on the value of a condition. Up next we have bitwise operators. This includes bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, left shift and right shift operators. From some of our earlier discussions, you might remember me saying machine language is made up of ones and zeros. So all the variables that you create are made up of multiple ones and zeros called bits. And bitwise operators are useful when you want to manipulate data on bit level. For example, let's make a is equal to 4 and b is equal to 4. And then let's store value of a or b in C. Note that this is a bitwise OR. If you write OR 2 times, it becomes logical OR operator. Both are different. And now let's print out the value of C to console. If I run this, we can see that value of C is 4, which does not make any sense. So to understand what exactly is happening here, let me show you the bit representation of these variables. For that, I'll first include the bit set header. And now I'll print the binary value of A. It is perfectly fine if you don't understand this line right now. You'll probably understand this syntax when we get to templates and standard template library. I'll duplicate this line 2 more times and will print out binary values of B and C as well. And now if I run this program again, you can see that we have values of all 3 variables in binary format. So this 0100 is the binary equivalent of 4. You can verify this by opening up calculator application and switching to programmer mode. If I type in 4 here, you can see that its binary value is 0100. So now let's see what bitwise OR is doing here. Basically, bitwise OR works similar to logical OR but on bit level. It performs OR operation on each bit of both the variables. So you can see that 0 or 0 is 0, again we have 0 or 0, then we have 1 or 1 which results in 1, and finally we have 0 or 0 which is 0. And that is how value of C becomes 0100. To show one more example, I'll quickly change value of B to 2. And now if we run this program, you can see that 0 or 0 is 0, then 0 or 1 becomes 1, next 1 or 0 becomes again 1, and finally 0 or 0 becomes 0. This makes binary value of C as 0110, which is equivalent to 6. We can again confirm this using the calculator app. So if you understood this, you can easily guess what bitwise AND operator does. It sets the bit to 1 if both the bits are 1. In this case, value of C will be 0. Next one is bitwise XOR. This is also called exclusive OR. The only difference between this and OR operator is that it returns false if both inputs are true. Then we have bitwise NOT. And similar to logical NOT, this one flips all the bits of given data. The last two are left shift and right shift operators. Basically, these operators move all the bits to left or right by given amount. For example, if I write a left shift 1 and run this, you can see that 1 which was at 3rd place from right is now shifted to left by 1. And this is not just 1, all the other bits are also shifted by 1. Similarly, if I use right shift operator and shift by 2, you can see that now all the bits are shifted to right by 2. Let's move to the next set of operators. These operators are called typecasting operators. These operators are used when you want to cast value of one type of data into another type. For example, if we have float f is equal to 34.2, and then for some reason if we want to store this data into int k, we can write like this. This will cast 34.2, which is a float, into an int. Such casting will result in data loss because int cannot fully represent floating type data. Also, you can write the variable name in brackets instead. Both work perfectly fine. Next operator is the sizeof operator. This operator returns the size of any given type or variable in bytes. So we can print size of int like this, and this prints 4. So this means size of an integer on my machine is 4 bytes. Similarly, you can check size of any other data type using this operator. There are 2 more operators called new and delete, but discussing them is pointless before talking about pointers and how memory is managed in C++, and we'll see that in some future videos. So for now, let's end this video here. From the next video, we'll start looking at flow control in C++. If you like this video, hit that like button. Maybe also subscribe to this channel to see more videos on C++, and I'll hope to see you in the next one.